Hello and welcome to class. Um, Welcome to class. So my icebreaker question for us today is, where is your favorite place to go? And I'll give my example. I really love Mongolian barbecue, BD's, stir fry, so good. I just load it up with everything basically. But you guys don't have to pick food places. It's totally fine. All right, you like Wendy's and get those Frosties, chocolate Frosties. Those are so good. I love those. Oh, you like to go to the park with your dog? All right, okay, Sally. Yeah, I wish I had a dog, but I don't. I plan to get one eventually. Yeah. Oh, okay. And you like the supermarket? That's very good. Okay. All right. Well, let's get into today's lesson. So today okay, you'll just see what we're going to talk about. Okay, so first you see this line segment I have on here behind me. Someone tell me, what is the length of this? Does anyone know? Okay, does anyone have any idea of how we can figure this out? Well, what have we been working on lately? We've been working with the Pythagorean theorem. Good job, guys. Okay, so what shape does that have? Does the Pythagorean theorem deal with? A triangle, yes. What kind of triangle? Good, Joe, a right triangle. Does anyone see how we can make a right triangle out of this line? Yes, good. So here is the hypotenuse, the hypponose. And then, so from here we can connect these lines right here, and then that will create a triangle, a right triangle to be specific, to be more exact. I put my little triangle right there. So I want to find out the length of this guy, but in order to do that, I have to find out the lengths of these, which I can do, because this I can't, because it kind of looks like 2, but the diagonal of these unit squares are not equal to 1. So we have to solve. And doing that, we have to use the Pythagorean theorem. Can anyone remind me of the formula? Good. So it's a squared plus b squared equals c squared. All right, and we've got which one do we want to be a? It looks like both of them are the same, so it doesn't matter. All right, we'll make this a and this b. Okay, so there's 2 ways that you can figure out what the length of these are, and I think John has an idea right there. Yeah, so you can see right away that this right here is 2 lengths. So this is 2 units, and then this also is 2 units. There's another way you can do that without even having to draw the thing, as long as you know these points. So it's going to be taking the absolute value of x1 minus x2, or the absolute value of y1 minus y2. And so the x will get you, if you subtract x from x, that's going to give you the horizontal value. And then if you subtract y from y, that gives you the vertical. So here we have, for x1, you can make, as long as the x1 and the y1 come from the same place, then we're good. So it doesn't matter which you have as 1 and which you have as 2. So let's have this as 1, this 2. So x1 is 1, minus 3 is negative 2 or positive 2. So we got that length right. And then 4 minus 2 is 2. And we got that length right. So those are the 2 ways you can figure out how to do it. With shorter lengths like this, I feel like it's easier to count, but if you like doing it this way, that's good too. If we get into bigger numbers, then this might be the way to go. Okay, so now I want to solve for the length of this guy right there. All right, so what do we do? Very good, so we start plugging in numbers into the Pythagorean theorem. So we've got 2 squared plus 2 squared equals c squared. And then that is 4 plus 4, good, Joni. And that is equal to 8, which is equal to c squared, but it's not equal to c, right? Right, c is going to be square root radical 8, and then don't forget your units, which unit here I didn't give a specific name. We're just going to have units as our unit. Okay, so this lesson today is basically I'm going to introduce using the Pythagorean theorem to find lengths of line segments like this. One that's not straight on the line where you could count 1, 2, 3. It's not on the line. You have to do the Pythagorean theorem to solve, because you can make a right triangle out of that. Okay, let's move on to the next problem. Excuse me on this. I kind of made my own whiteboard, so I gotta be a little bit creative with this. Alright, we're going to do the same thing we just did, but with real world problems. So I'm going to get my next marker. Alright, so let's say I live at the point 5 and then 7, all the way up here. That's a nice place to live. And then I want to travel to Boston, which is at the point 1, 2. Oh yeah, and I almost forgot to say, I'm changing it so each one of these units is equal to, 100 miles. Okay, so this is where I live, right here at 5, 7, home. And then I want to fly all the way to Boston, which is I don't know how many miles away it is. And Boston is at 1, 2. So I want you guys to help me figure out how long of a plane flight it is. Oh man, sorry, I'm a little jittery. How long of a plane flight, or how many miles we have to fly to get from my house to Boston. So I'm going to connect this. Whoop. All right, that's a little wiggly. All right, so what is my next step? Good, Sam. We have to make it into a right triangle so then we can apply the Pythagorean theorem. So let's make this right triangle. Good. All right. Now, what is this side length? And you can count it, or you can use the formula I gave you guys earlier. You want to raise your hand? All right. Yes. 4. Good. This is 4 miles. Oh, thank you. You got me there. Almost forgot. And this is 1, 2, 3, 4, 5. This is 5 miles. So using the Pythagorean theorem, which do we want to be A and which to be B? Anyone, whatever your heart's desire. All right, we'll make 4A and then 5B. So we've got 4 squared plus 5 squared equals C squared. All right, what's 4 squared? 16. All right, plus 25, thank you. And that is C squared. And that's 41 equals C, right? No, Miss Evans, what are you talking about? It's C squared. We still have to take the square root of 41. All right, so good catch. Thank you. All right, so the answer is radical 41 equals C. Well, radical 41 miles. So, well, wait, what did I say before? I said that one segment is equal to 100 miles. So this is actually radical 41 times 100 miles. And you can just leave it like that. All right? So radical 41 times 100 miles. Okay? All right. We're going to do 2 more problems. And these ones are going to be a little bit different. Oh, no. They smell like Sharpie. Okay. All right. So for the next one, So I'm gonna start at home again, and home is at the origin. Where's the origin? Does anyone know that special term? Good. Aaron, it's at 0, 0. So that's where I'm gonna start at home. All right, and then we're gonna drive. I'm feeling very hungry today, so I'm gonna drive to BD's. But actually, on my way to BD's, I was feeling a pre-meal Frosty, so I wanted to go to Wendy's. Yeah, I wanted to go to Wendy's for a chocolate Frosty, and I got my little. I didn't have an actual car. I only had a tractor with some Play-Doh in it, but I wanted to give you a visual of this driving across. So I'm first gonna drive to Wendy's, and that is 5 miles east. Where's the east? Yes, it's the Never Eat Soggy Waffles. So from this way, never eat. So east is this way. So we're gonna drive 5 miles east. 1, 2, 4, 5. All right. So here I am. I'm eating my Frosty, and then I'm going to BD's afterwards for my actual meal, which is 3 miles north. 1, 2, 3. Okay, so this one's a little different because I have 3 points, right? Yeah, so this problem's a little bit different because you can kind of already see a triangle formed, right? So I'm just going to connect these points, and that one's kind of hard to see. And there is our right triangle. It's already formed. And as I was speaking through the problem, I kind of gave you the lengths of these, right? Like I said, I start at home, and then I drive in my tractor all the way to Wendy's. Yum. And I drove 5 miles to Wendy's. So this is going to be 5 miles. All right, and I forgot to tell you at the beginning of this problem that one of these lengths is equal to 1 mile. So the last one was 100 miles, this one's 1 mile. All right, and then I said that I travel north 3 miles to go to BD's. So my question is, how long is it going to take me to get from BD's, or my bowl and barbecue, back home? Okay? So how do we do this? The Pythagorean theorem! Let's do this thing. Okay, we're going to switch it up. I usually do that one A. I'm going to make this one A and this one B. How's that sound? Okay. So 3 squared, which is A squared, plus 5 squared, which is B squared, is equal to C squared, which is this guy right here. We're going to figure out how long it's going to take me to get home. So we've got 9 plus 25 equal to C squared. And then 9 plus 25 is 34. Very good. C squared. And I'm not going to make the same mistake as I did before. 34 is not C, guys. There's a square right there. So to get C by itself, we take the square root of both sides. So that leaves us with radical 34, what? Miles, good. Equals C. All right, so that radical 34 miles, that's about how far it's going to take me to get from BD's to my house. Which, what does radical 34 mean? Well, let's think. What is close to radical 34? 36. Square root of 36 is 6. We know that. So it's going to take a little less than 6 miles, which is really close. I would love to have a BD's that close to me. All right, we're going to do one more problem, and then I'm going to let you guys loose. Okay, so I take my dog to the dog park. Yeah, just like she likes to go to the park. I take my dog to the dog park, my imaginary dog, because I do not have a dog. And this imaginary dog is a Boston Terrier. Yep, because I just flew to Boston. So my car I'm going to make it at 1-1. So there's my car. It's at 1-1. Oh, I almost forgot. One of these lengths is equal to 1 foot. All right, so I get out of my car, and my dog and I walk. We walk on a path forward, which we're going to call up in this. we walk 5 feet forward. So we're gonna go 1, 2, 3, 4, 5. And let me just mark that already. We already talked about how this was the last time I gave you the length, and then that was the length of the thing. That makes sense. So this length, I just said I walked up 5 feet, so I'm just gonna label that already. And then so my dog and I are walking on the path 5 feet, and he sees he sees a squirrel, and he turns to the right and runs 6 feet to the right. So let's go 1, 2, 3, 4, 5, 6. He stops at this point. And then the squirrel, he stops because the squirrel ran up a tree, and my dog just felt really defeated. So he was like, Miss Evans, we're going back home. My dog calls me Miss Evans. We're going back home. And so he takes me all the way back to the car. So how many feet did it take me to get back to the car? And then we said this. Okay. So we said that was 5 feet. How many feet did I go this way? 1, 2, 6 feet. All right, Pythagorean theorem time, my favorite part. So let's make this A and this B. So 6 squared plus 5 squared equals C squared. Here's C. That's how long it takes me to get from this tree where my dog gave up. We only walked for 6 feet. That was our journey. Okay, so then 36 squared is 6 squared is 36, and 5 squared is 25, and that equals C squared. And then 36 plus 25 is 61, do my math right, equals C squared. So radical 61, and what is my units? Feet, equals C. So can anyone give me an estimate about, like, what is that around? How many feet did we have to walk to get back to the car? Yes, Jimmy. 64 is our closest known perfect square, and that's 8. So, or the square root of 64 is 8. So the square root of 61 is going to be a little less than 8. All right. So that is it for today's lessons. We're going to do some guided work and then some independent practice. So for the guided work, I'm going to have you guys, I'm going to split you all into 4 groups of 5, and I have a map of the school, and I've marked on the map a path from one room to the other. And so it's like the path looks like this. I'm going to draw on this. It's like this is a room, and then this is a room. And then you and your group are going to walk and put your one foot in front of the other and walk until you get to the corner, and then count that and then write that as your length. So say it's 20. And then you're going to walk, after you turn that corner, you're going to count how many steps it takes to get to that next room. Say it's 30. And then you're going to pretend like there's no rooms and say, how many of these footsteps would it take me to get from point A to point B without having to maneuver around all those classrooms? And I'll let you guys figure out how to do that part. And then after you do that, come back to the classroom, and I'll give you I'll give you some graph paper so that you can draw all this out. And then after that, you'll come back to the room, and then we're going to have a little bit of an activity where you're each going to come up with your own lessons, just like we did either replicate it like the first 2 problems we did or the last 2 problems we did. So make your own problem, and then we're going to, and then you guys are going to give it back to me, and I'm going to shuffle them up and pass them out to other people. So someone in the classroom is going to get to do the problem that you made up for them. And I'll give you graph paper for that as well. And then after that, we'll just talk about how our day went and how everything was. So yeah, have a great day. Have fun, kids.